All right, let's get started. So today marks the start of Programming Test 2 content. So at this point, I'm done with Programming Test 1. I'll be happy to entertain questions if anybody has them. But by default, I don't have anything else to say about Programming Test 1. It's 100% in your hands. You have everything you need for it. And today we're going to start Classes and Objects, the Programming Test 2 content. So let's jump into it. Lab this week is going to be, I have it listed as quiz prep. It's going to be a sample quiz. We're going to go through a simulation of the quiz next week in this week's lab. So we're going to work out all the logistics, how we're going to do quizzes. So there are no surprises when you do the one that counts for credit. The quiz is going to look very similar to the one you'll see next week. Same concepts, tested, all that good stuff. Up to and including today's content. We'll see on that. And we're going to use an electronic system of doing traces. This is new this year, so if there are some hiccups, we'll get through them. That's why another reason I want the practice quiz this week, so we can all get used to how the quizzes are going to go. This is at tracing.csE.buffalo.edu if you want to get your hands on it right now. And it'll be an electronic way for us to create our memory diagrams and then submit your memory diagrams that you do in lab using this tool. Now, we used to do this with pen and paper. You would draw out your memory diagrams and hand them in. Then we had all the logistics that come along with paper submissions. So we're hoping this is going to smooth out a lot of those logistics. We can create stack frames of variables, code blocks, objects on the heap, I/O lines, and then submit electronically. So we'll start using this. Again, you want to get your hands on it right now. It is live, and we'll practice it this week in lab. And then as long as, assuming everything goes well this week, as long as it doesn't crash and burn. Again, it's a new tool, new software. There's usually things that go on with it. But as long as everything doesn't crash and burn this week, this is what we'll use for actually submitting the quizzes instead of using pen and paper, which is always a pain. Okay. Oops. Okay, with that, objects and classes. But yeah, this is homework. I keep saying homework, but programming tasks too. I forget I call them programming tasks in this class, but I call them homeworks in 312. I always get my brain confused. I confuse myself with that one. So objects and classes. So classes are used to create objects. Now, we haven't used classes for this yet. We use classes just to be classes, just to be a collection of methods, and they were all static methods. But then I introduced this array list class and the hash map class, and I said, hey, look, with array list, we can create a new array list using this syntax. Isn't that cool? And what I want to explore starting today is how do we write classes that are designed to do this? How do we write classes where we can say new and then my class and create what we call an object of that type? So we can create new array lists with this. How do we create our own classes that work the same way array lists do? And I mentioned this in lecture, but it's worth repeating just because I get this question a lot. If I want to create an array list in one line, I kind of snuck it in this example. This arrays.asList, this is going to let you put a comma-separated list of values and initialize your array list in a single line. This is easier than creating new array lists and then doing r1.add, r1.add, r1.add. Bless you. If you don't want to do that, here's a nice short way to do it. All in one line, create and initialize your array list, populate it with as many values as you want. A nice succinct way of testing that average method, where you got to give it a bunch of array lists and make sure you get the right values. This is a cleaner way. If you don't want to do this, don't worry about it. Don't do it. Just do r1.add, r1.add. No one would stop me from doing that. But if you do want a little bit of shorthand, here you go. If you do this, make sure you're importing arrays as well. Arrays, it lives in the same package as array list. It does need to be imported before you can use it. Okay, so how do we create our own classes that are used to create objects, which really is a big, I would argue the point of classes is using them to create objects. Now, Java doesn't let you have any code that's not in a class. So we had classes just to store static methods and had a collection of methods like that. But what we really want to do is create objects using our classes. So let's see this example. We're going to create a player class. It's going to be used to create player objects. So we're going to do new player and create player objects. And we're going to have it store 3 variables. We have 3 different values that we want it to store. The player's maximum hit points, current hit points, and name. So I want to know how healthy is this player based on their current hit points in relation to their maximum hit points, presumably, and the player's name. And this is what that looks like. So as always, I'm going to throw a lot of the code. We are going to expand this. We need some more. We need more stuff in this thing to make it work. But as always, I'm going to throw a bunch of code at you, and then we're going to break it down over the next 10 slides, because there's a lot going on here. There's a lot of new stuff on the screen. So let's break it down and talk about every part of this. So a class or an object, what they really are containers that store state in the form of variables and behavior in the form of methods. So I think of an object or a class. So far, we've been talking classes, but we're going to start talking objects. I say class in the slide, but I mean both. What an object is, I'll say object because that's the new thing we're talking about. What an object is a collection of variables and methods, state and behavior. It has state that it stores as the collection of values and all its variables, and behavior, which is the collection of all its methods. And the behavior can depend on the state. For example, if I have the size method of an array list, that method's behavior is going to depend on how many values are currently in that array list. So the behavior can depend on the current state. But state and behavior, that's really what an object is, really is what a class is. We've seen, we only saw one class variable, the epsilon, from testing doubles. But it can store variables. Usually we just saw collections of behavior in our classes. The problem set class is a collection of behavior. It's these 3 methods. They all have behavior with no actual state. With objects, we're interested in state as well. But state and behavior, those are the 2 things that objects and classes can have. You can't store anything else. Variables and methods, that's what we get. And we have these variables that are kind of hanging out here in a strange area of our code. We haven't seen this yet, so let's talk about this. Usually, so far, with the exception of epsilon at one time, we had variables that are either defined as local variables inside methods, which would go in the stack frame for that method, or variables declared as parameters for a method, which again go in the stack frame for that method. Here we have some variables that are outside of all the methods in a class. That's outside all the methods. So where do these go? The answer is going to be the heap. So spoilers, I guess. But these are what's called instance variables, and these variables will be created for every single object of this type. So whenever we create a player object, we're going to create that object on the heap, and it's going to get copies of these 3 variables. So every single player object will have its own copy of these 3 variables. Just like I can have 2 array lists, I can have an array list, I just create an array list and it's empty. I create another array list and I stuff 5 values in it. If I call .size, each of those array lists are going to give me different answers because they have their own copies of all the instance variables associated with an array list. So every player I create is going to have its own copies of these 3 variables. And these, I'm going to call them instance variables. There are a lot of different names for these variables. State variables, fields, object variables. Attributes was thrown out there in the last lecture. Somebody asked if they're the same as attributes. Sure. Lots of developers have different names for these. It's one of those things where there's just lots of different names for the same thing, and it can get frustrating, it can get confusing at times. But if someone says instance variables or state variables or fields or attributes or object variables, they're all talking about the same thing, and it just gets annoyingly confusing. Same with objects. I even am mixing up what objects are called. Objects or instances. You can create an instance of a class or create an object of a class. Everything has to have multiple names for some reason. So when I'm talking about these variables, I'm going to stick with instance variables this semester. Each semester, I kind of change often what I like to call these things. I try to pick the one that I think makes the most sense in lecture. And outside of lecture, I'll usually call them fields, just because I like one syllable, it's fine. But field doesn't really make sense to me. It's more of a mathematical term. Instance variables, they're variables that are associated with each instance of the class. So that's what I'll stick with this semester. I used to stick with state variables. In previous semesters, I would call them state variables all semester. I'll pick one for a semester. This semester, I'm sticking with instance variables. If I slip up and say one of these other ones, I do mean the same thing, I just messed up. Instance variables is what I'm going to call them this semester. So, and whenever you have a variable that's declared outside of all your methods, it will be an instance variable. There's no other choice for it to be. It's going to be an instance variable. I guess I shouldn't say there's no other choice. If it's not static, then it's an instance variable. And then we have this special method called a constructor. Why are instance variables set private? Would it cause any errors otherwise? When declaring your variables, do you need to use this? They're private by, I'll say convention. I have some slides on this. I'll talk about it more in depth when we get to those slides. But in Java specifically, it's common practice, it's best practice to have all of your instance variables private and not let anybody modify them directly except for code within the class itself. If we leave off this dot, everyone likes to ask this one. If I leave off this dot, Java will sometimes get the right thing. It will sometimes know what I'm talking about, but it sometimes won't, and in this case, it actually won't. If I do max HP equals max HP, it's not going to work the way I want it to. But if Java can figure it out, you can leave it off. For my money, I like to always be explicit and say this dot. If you don't always say this dot, I'm not going to get mad at you as long as your code works. I won't even get mad if your code don't work. I'll just help you fix it. But I always like to put this dot to be explicit about what I'm doing. Some of you who've used Java before know that you wouldn't write this dot, but I like to be clear in my code. Code should be easy to read. What is the purpose of instance variables? It's like a spiritual question. What's the purpose of instance variables? So I want two different, like if I want a multiplayer game, I want two different player objects in my game, each one controlled by a different human player. And I want those players to be able to be in different states. One player might be at full health, one might be at 1 HP left. With instance variables, they're allowed to have, they're each going to have their own copies of these three variables, and they can each be in different states. Without instance variables, we can't get those two objects in different states. They'd have to all share one variable, and that's just not going to work. Or it would have to be a variable that's within a method call. But what happens to those variables at the end of that method call? They're done. They're out of memory. They're erased. They're destroyed forever. Our instance variables are going to live longer. And if they're associated with objects, each object can have different values in their instance variables. I had to think about that one for a second. Like, I just use them all the time. How would I live without them? I had to think about how I would live without them. I wouldn't code, I guess. All right, so we have this special method called a constructor. When we saw new array list, I said this calls a special method called a constructor, and I kind of just left it at that. I didn't really talk about it too much. Well, now we're on the other side of things where we want to write constructors that people are going to call. So when we want to create a constructor method, this is the setup that we're going to use for that. So a constructor method is a special method that has the exact name as the class name, down to capitalization and everything, all has to be identical. And it has no return type. There's no return type here. It's the only methods we're going to see without a return type in Java. The return type of a constructor is always a reference of the type of object that was created. So this is going to return a reference to an object of type player. So we don't have to specify that because that's how every single constructor on the planet works. So we don't have to specify the return type. Or else it would be like public, player, player, and then the parameters. So other than those differences, this is mostly like any other method. And the fact that it has a parameter list and a body and stack frames, all that good stuff is all the same. And now with this special method, we can do that same thing that we did with ArrayList. New player. New is saying, I'm about to call a constructor. Whenever you see this keyword, you're about to see a constructor call. So new, and then call the constructor just like any other method call, the name of the method, and then an argument list matching the types of the parameters. That's going to create a new player object on the heap. Call the constructor method, go through the code in the constructor method, create variables for each instance variable on the heap, and return a reference to that new player object that was created. You become the purpose. And this is a kind of a slippery keyword in the sense that I get lots of questions about it. It's one of them things that takes a while to really get a handle of, to get a good feel for. So let's talk about it. This is a keyword that resolves to a reference to the calling object of a method. So whatever object was used to call a method, this is a reference to that object. And in the case of constructors like we have here, this is a reference to the object that's being created. So I say new player, and then this is going to be a reference to that player object that was created. So by the time the constructor is called, the object, the memory for the object, it's already been allocated on the heap. We have a reference number for that object. We have copies of our 3 variables, and then we can use this dot, follow the reference to the heap, variable name to set each one of those variable names or access the variable names. Yes?
Object, do you mean like the OX200?
Yes. Yeah.
If you want to make like a player with different attributes, like instead of like 12, like something else.
So if we want to create a player with different attributes, like instead of health, something else, we would either change this code or write a new class. So to get a little further with that answer, we're going to start talking about inheritance in 4 weeks. 3 weeks of content and then break in there. Where we can actually add functionality to an existing class. So if we don't want to create a whole new class, we could extend this class and then just add the state and behavior that we want to add to the player class. And then have like super player or something as the name of that class, and then create another type of player. Yeah.
Is there a limit to how many instance variables we can have for something?
Is there a limit to in general, no. Is there a limit to the number of instance variables we can have? Kind of no, but at some point you're going to start running out of heap space and your computer will start mounting. No practical limit on the number of them. And for what it's worth, you can initialize your instance variables in line right when you declare them. If you have some instance variables where you want the same initial value for every single object of this type, you can initialize them right here and say, okay, every single player is going to start with 10 HP as their max HP. Let's just hard code that here and take that parameter away from the constructor. Then you only have to specify your name, and everybody starts at 10 HP. I'm not going to do that in this example, but for what it's worth, and a lot of you probably have done that. If you've done Java before, you've done that. So I just want to throw that out there. That is an option. You don't always have to use your constructor to initialize your instance variables. And these instance variables are private. We've only seen one private variable so far. It was that epsilon. I threw some new things at you just to get some topics out there. Here's where we're really going to start using them. These instance variables are private. This is common practice in Java. Most, if not all, in this class, it should be all. I might throw a protected instance variable at you by the end of the semester. I didn't last semester, so I probably won't this semester either. But by default, all of your instance variables in Java should be private. Fun stuff. This is something called encapsulation. I say that because other languages, we don't have to worry about this and what's coming up. But Java, we do. So this is leveraging something called encapsulation, which I've always taught encapsulation, but I never called it out by name. So I make sure I start calling it out by name now. Because I had a former student have a job interview where they're like, what's encapsulation? And they said, I don't know. Nobody's ever used that word with me before. And then they followed up the question with, an example of encapsulation. And they're like, oh yeah, I know all about that. So now I make sure I get the name out there. Encapsulation. This is the idea of hiding details and exposing public interfaces. So we're going to hide all the details of our player class, which here are our instance variables. Nobody needs to care that we have a variable named max HP and a variable named HP. Maybe people can infer that they might exist, but they don't have to care. They don't have to know about these variables. And then whatever way we're going to let them access these variables, we're going to make those public and let people access our variables through the public methods. We see this in the array list class. I'm going to keep picking on array lists since it's one of the only two classes we know about. In the array list class, somehow the array list has to have an instance variable or variables that store all the values that you put in your array list. You don't, unless you've studied Java internals, you don't know what that instance variable is. You don't know what that looks like. And guess what? You don't care, or at least you don't have to care. All those details are encapsulated. They're hidden from you. The array list class just says, hey, look, add, get, size, these methods, they're going to do what you want them to do. Don't worry about how I got the job done. That's what the array list class says to you because it's using encapsulation. It's hiding the details and just exposing some public methods for you to use. And you use those methods, and you're none the wiser to how or why that works. Of course, by the time you get to 250, they're going to show you all about how an array list works. But you don't have to care. And when you write your code, don't force other people to care how you coded that. Just make it work. Make the methods that they want to use your code for, make those methods work, and hide the details. Yeah.
So like it's how companies hide personal information and other stuff?
Yes. So encapsulation usually isn't concerned with privacy necessarily, but it's the same kind of idea that we want to hide your personal information as well and expose only what needs to be exposed. Yeah. Yes. Yeah, I would count the constructor as a class's behavior. It is a method of the class. It's a special method, but it's still a method. So I'd say it's part of the behavior. Yeah.
Let's say I had another instance variable and I didn't use it in my constructor.
Mm-hmm. Yeah. Yeah, so if you had a fourth instance variable and you never set it to any value, you didn't set it in the constructor, you didn't set it in line up here, yeah, that's allowed. So Java variables do have default values. This isn't something I'll expect on quizzes, even when I accidentally do a setup where it could exist. But every Java value has a default, or every Java type has a default value. So if I say deleted my entire constructor code here, my max HP and HP would be set to 0 because that's the default value for an int. And string, oh, why do I back myself in corners like this? Default value for a string, I always forget if it's the empty string or null, but it has some default value that it'll get. Double is 0.0. Booleans, I think, are false. You'll get whatever the default value is for those variables. Not true in C when you get to 220. The default value for a variable in C, whatever was sitting there in memory. You get random ass stuff. It's crazy. Java will at least clear out memory and set it to the default values. Yeah.
So I can have
variables that are set to private, but if they're in a constructor and if the constructor is public, it's still accessible.
Yep.
Okay.
Yeah, so what private means is you can only access these variables. So this is my next, well, spoilers on that. I meant to build up to that. But private means that you can only access these variables from within the class. So anything in these braces for the player class can access these private variables. Anything outside can't. So even though I have methods that are called from the outside world, since they're public, they can be called from the outside world and access those private variables because the code that's accessing them is within this class. So that code can still be called from the outside the world, from outside the class. So if they're all private, how does anybody, I forgot to build it up, but how does anybody access our variables if we just have private variables and no public way to access them? Getters and setters, yay. If you've done Java, you love these, right? Getters and setters are frustrating, but we're going to learn to love them. You can have multiple constructors, so if you want a player with different variables attributes, you can do it with another constructor. Yes? Oh, somebody said no. We have conflict. Okay, that's what I was wondering. Thank you. Yeah, I mean, you can. Right? And let me I might have read this wrong. So if you want a player with different variables attributes, so it wouldn't change the variables themselves. Like you can't have a separate constructor which adds a new instance variable. But say you had a fourth instance variable that you only wanted certain players to be concerned about. You could have this constructor that just ignores that fourth variable, and then another constructor which does set that fourth variable, and then only use it if you know that you have that fourth variable set. This is a way to do default values too. If I have maybe private Boolean, this player has extra functionality equals false. And then a second constructor which says set that variable to true. And then in my methods, I can have if that variable set to true, then have different behavior. It's a way that I could get different behavior from the same class, from objects of the same type. It's kind of a hacky way to do it, but the way I described it. So it depends exactly what you want. But you can't have a second constructor that gives you a different set of instance variables. Every object of type player created using any constructor in this class is going to have the same set of instance variables. So if that's what you meant, no, you can't add a new instance variable that way. You could through inheritance that we'll learn in 4 weeks, as I mentioned. Then you can add instance variables that way. This is a war. But not just by throwing another constructor. But another constructor can set your instance variables differently, the values of them. You are wizards. Seriously, even after just 115, the things you can do, you're wizards. Isn't that like bootleg state patterns? Yeah, it absolutely is. What I just described, if this Boolean, do this. We'll talk about state patterns way later in the semester, but there are ways to get very different behaviors from objects of the same type with. It's a lot. We got a long ways to go before we get there. We're on getters and setters still. We'll get there though. We'll get to state pattern. State pattern is super cool. I like it anyway. So getters and setters. The state pattern is what your AO task, like that task 9, effectively, is the state pattern. So getters and setters. We're going to make public methods. Getters just return the value of your instance variable. Setters take in a value and set the value of that instance variable to whatever value it got. So in this way, we are exposing our instance variables to the public. Your question that you better be asking is, why the hell, why would we do this? This is terrible. I could have just made those variables public and skipped all of this. We don't do that in Java. We do that in other languages. There is a distinct difference here specifically because it's Java. I'll teach OOP in different languages and not talk about getters and setters one single time. Python doesn't even have access modifiers. You can't have a private variable in Python. Depends on the language. Java says getters and setters for a specific reason. But let's talk about why even getters and setters. So getters and setters, why? Control. In a word, control. We want to control our code, and we want to stop people from breaking our code mostly. So we have this player class, and presumably this is part of a game. We have a whole team of developers writing hundreds of classes and all kinds of code, complex code that interacts with each other in complex ways. And a lot of them are using the player class and using my instance variables. If I don't have getters and setters and I just say, hey, my instance variables are public, don't worry about it, just use my variables directly, what somebody's going to do, either intentionally or not, if they're on my dev team, hopefully it was unintentional, but they're going to write some code that's going to say P1, like player P1 equals new player, P1 dot HP equals 1 billion. And they're going to overflow their HP to some ridiculous value over their max HP. And I don't want that to happen. I mean, I'm storing my max HP for a reason. I want it to be the max HP. But somebody can write that code, and I can't do anything about it. If they say P1.HP equals 1 million or 1 billion, there's nothing I can do about it because I just let them access my variables directly, and I'm screwed. Once that code's out there, like I have to go to my coworker and say, look, you wrote dumb code. Let me talk about how we're going to fix this and everything. But if I have it set up with getters and setters, even if I set it up like the previous slide where my getters and setters had absolutely no functionality, they just did the same thing that people would do if they accessed the variables directly, even if now, after the fact, retroactively, somebody writes that dumb code, I'm going to go to my setter and add my logic to prevent that, to enforce some constraints. And I have that option because I forced them to call my setter. I didn't let them access my variable directly. Bless you. So now I just add code to my setter, and I fix that bug. Somebody tries to overflow their HP. Well, now they can't. Same thing with getters. A similar thing with getters. Say get HP. I'm going to return the value of HP, and that's fine. It's just the default value, the default behavior for now. But what I'm doing is forcing everybody to route their calls through this getter. And then later on down the road, maybe I don't want to just straight up return the HP. Maybe I want to return a percentage of HP compared to their max HP and return that percentage as the HP that people are getting. Maybe that's what we decide the project should do. Well, now I changed my code in the getter, and everybody should update their code to expect percentages instead of HP. And then everybody's getting the percentages now, as opposed to everybody saying P1.HP and then everybody else in the project converting that to a percentage. They don't have to do that. I'm just going to change my getter, and they get the value that they want. So that's what we want, control. Now, we don't do this in other languages. A lot of languages have a way to add getters and setters after the fact. So you can add your getters and setters, and the same exact syntax is used as if you were accessing the variable directly. So that's why you'll never see this in Python. I never talked about it when this course was in Scala. C#, you'll never see in C#. Because they have ways to add the getters and setters after the fact, and the code that somebody else writes is still going to say P1.HP equals whatever. Unbeknownst to them, it's calling a setter instead of being a direct variable assignment, because we can add that setter after the fact like that using the same notation. So we don't worry about it in some languages. Java doesn't have any fancy fix like that. So Java, we're still stuck with getters and setters and private instance variables. Okay. So that's why getters and setters. I hate justifying getters and setters, though. It's so annoying using them all the time. But it's Java. We're using them. It's the right thing to do. So, and you can, this is optional, but you can call your setters in your constructor. In the memory diagram, for what it's worth, I'm going to do this. Calling your setters from the constructor. Now, this is really useful if you have logic like this. In this exact example, it doesn't quite make sense because you're setting your HP equal to the max HP, so you really don't need the check. But in your homework, in programming task 2, you have the rating class, and when you call set rating, you have to verify that that rating is between 1 and 5. We don't want people giving a score of 1 million to a song. We also don't want them giving negative ratings or zeros. You have to do 1 through 5 as an integer. So in the setter, you'll have some logic that says, hey, make sure that this is a valid rating. And you'll also have to do that in your constructor. Hey, make sure this is a valid rating. Now, you could cut and paste that code into the constructor from your setter, or just call your setter from your constructor, and now you're reusing the code instead of duplicating the code, which is always better. Or do it this way. Either way is fine. And we have no static anything in this class. Nothing is static. Nothing at all. When we have classes, really for most of the rest of the course, we're not going to have static anything. In homework assignments, in the descriptions, if I just say, write a method, blah, 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 and I don't mention anything about static, that's a non-static method. I'll explicitly say if it should be static. If I don't say anything, it's non-static. Is this how people cheat in games? They change the variable sometimes? Yeah. Is there a way to check if an instance, and it depends on the game. If it's an online game, the server should be checking for that stuff. But if it's fully offline, yeah, you have access to the stack and heap. You have access to memory. You can access your own memory. Nobody's going to stop you. You can change whatever you want. Usually, never mind. Let's not go down that road. Can't believe it's not static. Yeah, you can get it like cheat engines, especially for common platforms. You get a Unity cheat engine. You can modify all your values. Is there a way to check if an instance variable is private with JUnit, trying to directly access it with their own error? Yeah. So like in my tests, oh, do I even check that? You might get away with public variables in my tests. But you can't, oh. Yes, the short answer, I got to move on with the slides. But the short answer is, yes, there is a way. I don't do that, at least not yet in my tests. All right, so nothing in this is static. The difference between static and non-static. Static variables and methods belong to the class. In problem set, in programming task 1, problem set dot average. You're calling that method through the class itself, the problem set class. When a method is non-static, it belongs to the object created using that class. So when you create an array list, new array list, put it in R1 or whatever your variable name is, my array list dot size, my array list dot add, you're calling it through the object. You don't do array list dot add. It's non-static methods. We're going to call them through objects. We're creating an object of type player and calling these methods through that object, not the class. That's the difference between static and non-static. And once we create a class like this, and this was always true, but it wasn't interesting before, what we're doing is creating a type. Every class defines a new type, and now that we have a type, we can create player objects. What we can do is anything we can do with any other type. We can create variables of type player. We can create methods that take references to, I won't always say reference to a player, an object of type player. We can have return type of player. We can have an array list of players. We can do anything we can do with any other type, aside from our primitive types, which are a little bit different. But any other class type, we can do everything with our new type that we could with any of the other ones. And everything that goes on the stack, double, int, char, boolean, we pretend that strings do. We'll also pretend that our auto-boxed types, our class types, type equivalents of the primitives, go on the stack. I won't do that on a quiz or lecture example or anything, but if it ever did come up, we would throw those on the stack as well. So what goes on the heap? Everything else. Everything else goes on the heap, including any objects that were created from classes that you wrote. Everything else goes on the heap. There's not much that goes on the stack at all. The stack has our primitives and a bunch of references. And that's it. Everything else goes on the heap. And there's even exceptions to that. If a variable is of one of these types and it's an instance variable, well, that's also going on the heap because it's part of that object. So our int for HP and max HP, those are actually going on the heap because they're part of that object. They're those objects' instance variables. But these are the only ones that go directly on the stack if we create a variable of these types in a stack frame. Okay, let's get to the memory diagram. Oh my goodness, I took too much time to get here. But we'll get through some good bits here. So we'll go back to more conceptual content on Wednesday, but I do want to get to an example quick. I wanted to get to it sooner, but let's do this. Which is weird. I had more questions last time. I must have rambled more here. So let's just do this. So let's do a stack frame. Starts off similar enough. Actually, it doesn't. The first thing is different. What am I talking about? So we get to this constructor call. Whenever we see the keyword new, we know we're calling a constructor and creating a new object on the heap, and we're going to get a reference to that object. So with our objects, we're going to create, similar to the way we did array list and hash map, we have two columns, one for the instance variable names and one for their values. We're above the object, we're going to put the type of the object. And for array list and hash map, we didn't put the type, but we really should. In the memory diagram tool, the electronic tool, you'll put the array list or hash map there. I guess I can't get mad if you don't, but the type of the object, so this is an object of type player, and then we're going to make up a reference, whatever number you want. I was feeling 999 when I made this slide, so I chose 999 for this. And then we're going to create copies of every single instance variable for this object. So we created a player object. We're going to look for all of the variables that are outside all the methods. Those are our instance variables. Create a copy of every one of those and put them in that object. They are part of that object. They're that object's state. And the constructor is a method call. It's a regular method call. So it goes on the stack. It's a stack frame. We put the name of the method next to it. We put a return arrow for the return value. We put the parameters on the stack, inside the stack frame, equal to the values matching the arguments. The big difference here, and I put this notational note in the worst spot. I'm going to stop drawing my arrows for the references. Just for the slides, I'm going to color code them so it's still clear which reference refers to which. But we're going to have a lot of arrows if I add them. It just clutters up the slides. I'm not going to clutter up my slides. So the big difference with our constructor call, and in fact with every single non-static method call, we have a hidden parameter. It doesn't show up anywhere in the code, really. It just kind of pops out of nowhere. This is basically a hidden parameter, which is going to get a reference to the object, to the calling object, or the object that's being created, in this case of a constructor call. And that does go in the stack frame. We're going to have a reference this, which for this constructor, a reference to the object that's being created. So this reference 999, I don't care what numbers you choose for your references, but you need to be consistent. So whatever number this is, you got to have the same number here. And then this is a reference to the calling object. Dot means I know this is a reference, but let's follow that reference to the object to which it refers, and then call the setMaxHP method. So what we're doing is going this, dot, follow the reference to the object, and then calling setMaxHP while we're at this object in memory. So that is the calling object. Whatever object we were at when we called the method, that's the calling object, and that's what gets that's the value for this in the next method call. Now, right now, there's only one object on the heap, so of course it's going to be 999. But if it weren't, whatever object we're at when we call that method, we called setMaxHP while we were at this object. So this in setMaxHP is 999, and then the parameter set to the argument, just like any other method call. Then this dot max HP, we got to resolve these two variables. This dot max HP, this dot means follow the reference, max HP, we find this variable right here. We resolve the right-hand side of the equal sign separately, so when we evaluate this one, we're not at the object yet. We're in the stack frame still, and we find max HP right here, which is the value 10. So this max HP here gets the value 10. I'm going to start graying out my slides, another notational note, or my stack frames. I'm going to gray them out instead of crossing them out. That's just for readability in the slides. If I cross everything out, it's hard to read what those variables were. I'm just going to gray them out. But this stack frame is no longer in memory. And what we just had was a stack frame that returns void that actually had an effect on memory after it's called. So we went to the heap, made a change, and saw that change after the method call ended, even though it didn't return anything. Same thing with set HP. Same thing with set name. And then when the constructor ends and that stack frame ends, it's going to return a reference to the object that was created into P1. And here's where I'd normally quiz you, but we don't have a ton of time. What happens when we initialize P2? If you said the exact same thing, you're completely right. I chose a different number for my reference. Same logistics happens, same thing happens. And then for P3, what happens when P3 equals P1? Hey, my music isn't starting again. That's twice in a row my music ain't doing what it's supposed to do. This is just assigned by reference. So P3 equals P1. P1 is OX999. P3 gets OX999. Assigned by reference. Which that actually is where we got in the other lecture, so I'm fine with that.